Hi guys, today's lesson is misleading graphs. It doesn't come from a particular exercise in the textbook, but I'll run you through the worksheet. It is a well-known fact that statistics can be misleading. They are often used to prove a point and can easily be twisted in favour of that point. The purpose of this lesson is to learn how to recognise common statistical deception so that to avoid being misled. So I put a graph here that's supposed to show us the average female height per country. So if we look at it, the author has chosen these icons to represent the height in inches, but due to the proportions, it's making it look like, the Indian women are these tiny little smurfs compared to these, giant Latvian women. So what the author's tried to convey hasn't really worked out for the audience. So over the next few slides, we'll look at, what makes a good graph and what makes one a bit misleading. Before we look at the graphs, it's important to assess the actual data. So when you use a sample to represent a larger group, you must make sure that the people in the sample are representative of the larger group. So we have to choose a sample so it represents the whole population fairly. So bad sampling is an unfair example and good sampling is a fair example of the population. For example, members of a dog breeders association were asked whether cats or dogs make better pets. So they've asked members of a dog breeders association whether they prefer cats or dogs. So this is an example of bad sampling. They're more likely to prefer dogs because they're dog breeders. Next example. Every fourth person who enters a supermarket is asked which size shopping trolley they like to use. The survey is conducted over 7 days and at all hours. So in this case, it's every fourth person. So this is like random. So they're chosen at random. And the survey is also conducted over 7 days and at all hours. So they're going to get all types of shoppers represented. So this is good sampling. Good graphs are extremely powerful tools for displaying large quantities of complex data. They help turn the realms of information available today into knowledge. Unfortunately though, some graphs deceive or mislead. So this might happen because the designer chooses to give the readers an impression of, better performance or results in the situation. In other cases though, the person who prepares the graph may want to be accurate and honest, but they mislead the reader by poor choice of graph or poor graph construction. So these are the important things to consider when looking at graphs. The title, letting us know what it's about. The labels on both axes of a line or bar chart and on all sections of a pie chart, so everything labelled. The source of the data, so where it's coming from. A key to a pictograph, so without a key we don't really know what it's telling us. Uniform size of a symbol in a pictograph. Scale, does it start with 0? If not, is there a break shown? And as well as scale, we're looking at are the numbers equally spaced? Here are some examples of some misleading graphs. So if we look here at the size of the pictograph symbols about food sold in one day, from first impression, it looks like ice cream cones were what was sold the most in one day. But if we actually count, it was fries. They've just drawn the icons not to a uniform size. So I just want to quickly show you about scaling and axis manipulation. So a graph can be altered by changing the scale of the graph. For example, The data in these two graphs are identical, but the scaling of the y-axis changes the impression of the magnitude of the differences. This is another one that's misleading because of the scale and axis manipulation. So it's looking at the average class score between Mr. Jones and Miss Smith. So it looks like Miss Smith's class is so much better, got such higher average. But if you actually look on the side at the scale, Mr. Jones's class average was 73.2 and Mrs. Smith's was 74. So there's actually very little difference, but it looks like Mrs. Smith's is about, 5 times better than Mr. Jones. And here's an example where the source of data isn't representative of the population. So it's looking like, this is when Trump was obviously still president, that 88% of people approved President Trump. But as you can see, it actually says it's been surveyed among Republicans, so from within his own party. So it's not representative of the entire population of America. I'll just run through a few other examples before we get started on the work. So this one here, this is looking at top artists. So it looks like Drake is, so far ahead of all of the others. But if we actually made it not a misleading graph, and it was scaled correctly and things like that, it would look more like this. So Drake isn't actually that far in front of the other artists. This one's looking at global warming. So it looks like, there's hardly any change because of the scale they've chosen over those years. But if actually they chose a scale that showed more data points, then it would look like this. And this last one here is showing your credit score. So it's 634 out of 700. So this infographic makes it look like it's a really bad credit score, but it's just the way it's kind of been displayed. So if it was displayed more accurately, it would look like this. So that makes you think, hey, my credit score is not actually that bad. Could you please complete the worksheet and submit to my Panola?